Hi everybody. We're going to be starting with the notes for topic 6.2 stratospheric ozone. And to begin with, this is going to be two different parts, so make sure that you take the notes on both parts. So let's talk about ozone to begin with. What is ozone? Well, it's found in two different layers of the atmosphere. I'm sure that you all remember that from when you did your drawings of the atmosphere. In this topic, we're going to be talking about it in the stratosphere. Topic 6.3 is going to be talking about it in the troposphere. When it's in the stratosphere, it's considered good ozone. When it's at the surface level in the troposphere, it's considered bad ozone, and it's a big part of smog. Like I said, we'll talk about that more in 6.3. So when we talk about good ozone, the benefits are that it allows the lower it allows into the lower atmosphere a limited amount of the UVB and the UVC, which are the more damaging ultraviolet radiations. You find this ozone layer between 20 and 40 kilometers off the surface of the Earth or above the surface of the Earth. And the ozone and the oxygen in this layer are in what's called a dynamic equilibrium. I've put down the chemical equation. 3O2 is in equilibrium with 2O3. O2 is oxygen, what we breathe in the atmosphere, and O3 is ozone. Now, this all occurs in the presence of UV radiation. So, this chemical reaction that we saw that's in dynamic equilibrium, where you have oxygen becoming ozone and ozone becoming oxygen again, this is taking presence in the presence of UV radiation. This UVA radiation that is absorbed, some of it, and some of it let through to the surface of the Earth, is very important because life could not exist on Earth without the ozone layer to filter out the excess UV radiation. So the UVA, which is all let through the ozone layer, is harmless, and it's got low energy, and therefore, from physics, it's got the longest wavelength. UVB, some of it's let through, some of it's not, but most of the UVC radiation, which is the most harmful type of radiation, the shortest wavelength with the highest energy, is absorbed by the ozone layer. So without it, we'd have some really bad side effects. We're going to talk about those in a little while. This basically shows the chemical reaction that I talked about. If you look up here, we've got the sun and its energy and shining down on oxygen. And what happens is the oxygen molecule splits into two atoms, oxygen atoms, which combine with an oxygen molecule, O2, to form ozone. Okay, so I said that we could have some damaging effects of radiation. What can happen if we have too much of the bad radiation and the ozone layer doesn't absorb the worst of the radiation? Well, we can get some changes in our DNA, which are called genetic mutations, which we would pass on to the next generation. We would have damage to our living tissues, and this goes from everything from skin cancers to sunburns. Okay, This would mean that we would have more cataract formations in the eyes, and probably at a younger age, because cataracts are typically, you get them with elderly people, and this is where the denaturing of the proteins occurs in the lens of the eye, and so the lenses in the eyes become cloudy. There's common operation to fix that, but wearing sunglasses and making sure our ozone layer stays intact are easy ways to counteract that. Skin cancers would mean an increase in skin cancers would be causing more death than we would need. And in order to avoid skin cancer, you need to use sunblock when you're outside, even if you're walking around, especially at the beach, and wear clothes that cover you. I know that it's not current fashion to be covering up with clothing, but you're going to be doing your older self a lot of good by making sure that you are covered up when you're outside and at the beach. Too much UV radiation suppresses your immune system, and too much UV radiation damages photosynthetic organisms and also damages the consumers of those photosynthetic organisms. Both of these can occur, can cause damage to food webs, and then you're going to have specific groups of animals and plants that die off, and that will cause a lot of interruption in life cycles on this earth. Okay, so not everything is bad. UV radiation has good. We do need it. It stimulates the production of vitamin D. When the sun shines down on us when we're outside, we make vitamin D in our skin. And we need that to avoid vitamin D deficiency diseases like rickets, which is a problem with your bones. Now, you can't really be outside getting vitamin D and taking walks around in certain times of the year and in certain climates, like people in Canada and Finland are not taking long walks in the sun during the winter. It's too cold. They're going to have their coats on and gloves on and hats. There's no exposure to the skin to the sun. So oftentimes milk and dairy products are fortified with vitamin D in order to make sure that you don't develop these diseases. Vitamin D is also used, and so is UV radiation. They are used to treat skin diseases like vitiligo and psoriasis. Psoriasis causes big itchy patches on the skin that are kind of raised up and red looking. And I do know that UV radiation really does help with this. A friend of mine's mother had psoriasis for years and years and years and years and years. And she was a neighbor of mine as a child. And whenever it was sunny enough and warm enough to be outside with your bathing suit, and she wore her bathing suit outside in, I think, pretty cool temperatures. She was outside with her swimming suit on so that she could feel the sun on her psoriasis, and it did a world of difference for her. It really made her feel a lot better. UV radiation is used as a sterilizer, an air purifier, and a water purifier. Concentrated UV radiation, even now in the middle of the coronavirus pandemic, is being used to sterilize equipment in hospitals so that it can be reused again because they're in short supply. It's often used to sterilize surgical instruments that are reused and reused, like scalpels and things like that. And you also have UV radiation used obviously in lighting, for forensic analysis, and in lasers. One nice thing I wanted to say is UV radiation kills pathogens and especially bacteria. So I'm hoping that with the warmth and the sun, that helps keep down the UV radiation. Since all of us are in quarantine, maybe the sun will help kill off the pathogens for coronavirus in the air, like it does for the seasonal flu. So, what's the ozone hole? The ozone hole is a break in the ozone layer, a hole, that's directly above Antarctica in the stratosphere. Now, the hole varies in size and shape, and it varies in size and shape seasonally as well. The lowest amount of ozone decreasing is during the springtime in the southern hemisphere, which is September and October. And it increases over the summertime and into the winter, which starts in November. Summertime starts in November, December in the southern hemisphere. Scientists have been measuring the size of the ozone hole since the 1950s, and it's been growing steadily. And the thickness of the ozone layer has also been decreasing steadily as well. Why is this happening? Ozone depletion, it's a result of man-made air pollution. The chemicals that we use, CFCs, are depleting this layer. This is all on us. It's all our fault. CFCs are a classification of compounds called halogenated organic gases. Halogenated means that there is part of the chemical formula a halogen, chlorine, fluorine, bromine. These are examples of atoms that are in the second to the last right-hand column, which is called the halogens on the periodic table. Organic means that they have carbon in them, and obviously they're gases. CFCs, HFCs, and HCFCs are all part of the halogenated organic gas family. So here is pictures of the hole in the ozone layer. Now you can see that this is a view from Antarctica. The continent is drawn into the picture. And as I said, not only does it vary seasonally, but the hole shape and size varies daily. And this shows you 5 days in November in 2018, exactly what the hole in the ozone layer looked like. So we're going to stop right here for this slide. We're going to start the next video with this slide. So hopefully you can shut us down, and we'll start right back up here for the next set of notes.